Today I am going to explain you recursive descent parsing and its implementation using C language. Recursive descent parser is an top-down parser. It will verify whether the syntax of the input stream is corrected by checking each character from left to right. A basic operation is necessary for reading characters from input stream and matching them with terminals from the grammar that describes the syntax of the input. Recursive descent parser consists of several small functions, one for each non-terminal in the grammar. That is, we write a routine to recognize each left-hand side. This produces a parser with mutually recursive routine. As we saw in previous video that top-down parser having some problem with left recursion and left factoring. And while applying the productions, sometimes it requires to do a backtracking. Backtracking is needed in recursive descent parsing, and without backtracking in recursive descent parsing is a predictive parsing. So we'll look for an example of predictive parsing. In this example, A derives A, B or B. Then we will write a functions for this grammar. A is a function, that is, for every variable there is a function. Take an example, A is a variable, and for this variable there is a function that we called A. In this function, the first input will be A, then we have to use a pointer that we called as a look ahead. It is just like it will take a character from an input. So what is first input? That will be A. So if look ahead is equal to A, then match A. Match is nothing but at every match a look ahead is pointing to the next character. Then the B, again B will be the function, that function will be called and it will return back. The next character will be B. So we can say that else if look ahead is equal to B, then match. Again match is nothing but it will look ahead pointing to the next character. If there is no matching, then will error. It will generate the error. Recursive descent parsing. In this function A, it chooses the productions that A, x1, x2, dash 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 xk. For I is equal to 1 to k, if xi is a non-terminal, call procedure x of I. Else if xi equals to the current input symbol A, so it points to the next symbol, else it generates error. Take an example. In this example, what will happen? This E derives E plus T or T. At every E, it will go in infinite loop that we called as a left recursion, because it generates E, E plus T, again E, E plus T, for that E, again E plus T infinitely. So we need to do an left recursion to be eliminated. So after eliminating left recursion, we have this grammar, and after using this grammar, we have to simply move from one character to next by checking whether it follows the grammar, this grammar. Then the function for every variable will start with E, that is our first function. It derives T E dash. We have to write down simply these two functions inside this. E derives T E dash. Then what is E dash? Again E dash, it having the plus symbol and TE dash or epsilon. For function E dash, the first input symbol must be plus. If match, then it will go for T and E dash. Again, for the next production, that T FT dash. Again it will write the same way, F and T dash. Then T dash, what is first input symbol is multiplication sign. If input symbol is multiplication sign, then match. Again, what is match? Match is nothing but at every match a look ahead is pointing to the next character. So again it will point to the next character, then it will call F function. After executing that F function, it will return back, then again it will call T dash. You can say dash or prime also. Again, what is F? F generates either expression into parenthesis, or A or B. In this function, what will happen? If input symbol is left parenthesis, then it go for match for left parenthesis. Then it called E function, that is variable for E. If next symbol is right parenthesis, then again it will call match parenthesis, else it generates error. F can also derive A or B. If input symbol is not left parenthesis, then it go for else. If input symbol is A or B, then match. So by using this grammar, we are going to write a C program to check whether the expression is accepted or not. If input expression is A plus B, then it is accepted. If input symbol is A into bracket B plus C, then it is again accepted. If input symbol is A into B plus C, again it is accepted. Then if my input symbol is A into left parenthesis B only, then it will reject it because right parenthesis is not matched. If my grammar doesn't consist any minus sign in the expression, that is E derived E plus T, then that minus sign is not there. Then we have to rewrite for minus also. Again, if there is divide, again we have to write down the divide also. Then we can conclude that we can obtain a grammar that can be parsed by recursive descent parser that needs no backtracking by eliminating left recursion. I will explain how we can write down a function in C language to check whether the given expression is valid or not. Again, this is recursive descent parser for the grammar. In this grammar, E derives E plus T or T into F or F, and F can be expression or A or B. We have to eliminate left recursion first, then we can move from one character to next character by checking whether it follows the grammar or not. So rewrite the grammar to remove left recursion. E derives T E dash or E prime. E dash derives plus T E dash or epsilon. T derives FT dash and T dash derives star FT dash or epsilon, and F derives expression or A or B. Then we are taking the expression in a string as an input. Then there are two variables, one is index and one is error. every variable we are going to call a function. So variable is E dash, T dash and F. So for all variables we are writing a function. The first variable will be E. So in this main function we are going to accept an expression by using scanf statement, and then variable E I am going to call a function E. Then I will come back and then I will explain this part. What happens when variable E called? If you want, you can print E derives T dash. It will call the first T function and then E dash. What happened in T function? Here simply in T function it calls again ft dash. Then we will go directly into the f function. We are going to check whether f is having any left parenthesis or not. If left parenthesis is there, then it will match, increment to the next character or input. Again it will call E function if left parenthesis is there. Okay, else it will call is alphanumeric function str index is equal to I. It will be your first input. If your expression is a plus b, then it will match here and it will display as a and index will be increments. Again you will go back to the E function, then it will be recursive functions. All the functions are called recursively. The first one is T, then in T ft dash. Once f is over, then you will go back to T dash. Okay, if your expression is a into b, if your plus sign is not matched, then it will go to the T dash function. Again it will check for multiplication sign, it will match, then again it will call f and T dash. So in this way all these functions are called recursively and it will match your expression as a plus b, then it will valid. If your expression is a multiplied into bracket b plus c, then this parenthesis consists of b plus c is again it is called as an expression. That expression again it is validated. If it is valid, then it will go for next. So in this way you are going to check whether the entire expression is accepted or not while displaying this rule. In this a plus b, what happened? It will first call T dash, then T call ft dash, then f call id, then it will match. The next symbol, the next function will be E dash, then E called plus T dash, then T call again ft dash, f called a or b, then string is accepted. If I called string id into id, or you can say that a minus b also, then it will generate error after this because only plus sign is there. If you want to modify it, then you can rewrite the grammar for minus also. In this way you can check whether the given string is accepted or not. Thank you.